Hi, so today's topic is combining like terms and evaluating expressions. Our essential question today is, what do we do when we know the value of the variable? So before we begin, we must review combining like terms. We've already gone over this in class before, but let's just do a little review. So combine like terms, or how I like to write it down is CLT. It's a tool used to make expressions simpler. So sometimes you'll be given a really long expression, but then in order to combine like terms, you can make it simpler. And what do I mean by this is you can combine terms that are simply alike. So there's multiple rules in order to do this. The first one is that the variable has to be the same. That's the first rule, and I'll show you what this means. So for example, you can be given 2x plus 3x. Those can be combined because they have the same variable of x. 2x plus 3x is 5x. Or, sometimes we're not always given x. Sometimes you have y plus y, which can be combined to be 2y. Though they have the same variable, that's why they can be combined. The second rule is that the exponents have to be the same. And we haven't dealt too much with exponents, but say for instance, so an example would be if I gave you the problem x squared plus 2x squared can combine, because this is 1x squared, this is 2x squared, together makes 3x squared. The last rule is that numbers without variables, so this is without variables, can go with other numbers that also have no variables. So, two numbers without variables can combine. So for example, this is a more common example that you usually see, 3 plus 4 can combine to be 7. So remember, x's can only be combined with other x's, y's can be combined with other y's, and then they have to have the same exponent. X squares can combine with other x squares. Numbers can be combined with other numbers. You cannot interchange these. You cannot combine a 2x with an x squared or an x squared with a number. That's not possible. So, I want to highlight one main point. Along with combining like terms, in order to combine like terms, you have to use the plus or minus sign that is in front of the number before the variable. Or in other words, before the term. So what I mean by this is, once I give you an example, we will see how you can use the plus and the minus symbol that's before the term. So let's say, for instance, I give you a longer example. So previously, those are short and small examples. Now let's say, for instance, I have 3x plus 5x plus 7 plus 9x minus 4. So this is now what I mean by having a longer expression, combining like terms to make it simpler. So 3x is my first term in my expression. So I'm going to look for any numbers that can combine with 3x. So 3x, 5x also combines because they have the same variable. So does 9x, and they have the same variable and the same exponent. So then I can do 3x plus 5x plus 9x. And if I notice there's a plus sign before each of the terms, so I know I'm adding them. So then I'm left with 17x. And now, if I look at what's left, I have a 7 and I have this 4. They can be combined because they are both numbers without variables. In front of the 4, though, there's a subtraction symbol, or you can consider it as a negative symbol and saying 7 plus negative 4, or 7 minus 4. It will get you the same answer of 3. The 3 is positive, so I'm adding, and that is my final expression. So, along with this C note, we are also discussing how to evaluate expressions. So now, a part of that essential question was asking you, what if we know the value of the variable? So now I'm changing up the question just a little bit, and I'm saying evaluate if you know that x is equal to 2. So now, just like we did when we checked our solutions in chapter 6, we know that if x is equal to 2, then we can just change what x is and substitute it back into our expression. So now we have 17, 2 is in our parentheses, plus 3. And we know that a number next to another number within parentheses, that's multiplication. So 17 times 2 is 34. Just drop everything else down, plus 3. Now we have 34 plus 3 is 37. Remembering the order of operations will be important. You would have to multiply before adding. So, once you have this, we're moving on. We're going to try some more examples. So now we are going to try an example like so. We're going to say that we have 7m minus 6 minus 5 plus 2m. Remember, any letter can be used as a variable. Right now I'm using m as a variable because it means the exact same thing as x. So, now I'm going to circle my 7m. I see that 7m and I look to see what else it can be combined with. I see this 2m to the side. So I know 7m and 2m, they have the same variable and they have the same exponent, 1 or no exponent. So 7m plus 2m is 9m. And then I look at what's left. I have a 6, and it does not have a variable, and so does this 5. It also does not have a variable. So now I'm going to look at the sign before each number, and I see the 6 has a minus or a negative in front of it. The 5 has the same thing, minus or a negative. You can look at this as negative 6 minus 5, or you can look at this as negative 6 plus negative 5. Will give you the same answer as negative 11 or minus 11, depending on how you look at it. So now my final answer is 9m minus 11. So now I just talked to you about evaluating. So just like how we checked our solution, they're going to say evaluate as if you know that x is equal to positive 4. So now that I know x is equal to 4, so instead of m, I'm just going to substitute 4. Oops, sorry. This should be m. So m is equal to 4, not x equals 4. So now that I know that m is equal to 4, I'm going to substitute 4n for m, and then minus 11. So now instead of putting m, I'm putting 4. You do not need to put both. So, according to my order of operation, multiplication comes before subtraction. So 9 times 4 is 36. And then everything else I'm just going to drop down, minus 11. 36 minus 11 is 25. Final answer. So, these are the type of problems that we're going to be seeing when it comes to combined like terms and evaluating expressions. There's one more type of problem that I want to show you and give you an example of before you try these on your own. So this is just a little bit of an extra challenge. So, in this extra challenge, sometimes you'll be given problems such as you have 3x squared plus 4 plus 2x minus 6 plus x squared. I want to give you this example because we haven't done too much with squaring, so I want you to be able to know how to do it because you will find it on the next page. So if I combine like terms, my first term is 3x squared. I'm going to look for what other term can 3x squared be combined with, what has the same variable and the same exponent. I see this x squared over here. It can be combined. So 3x squared plus x squared is 4x squared. So now I'm going to go to my next number with the variable. And now I see this 2x. I look for any other x variables, and I don't see any. So I just drop it down. So plus 2x. What I have left over is 4 and 6. I see that there is a plus or a positive in front of the 4. So I know that's going to be a positive 4. And I also see this minus in front of the 6. So I excuse me. So that could either be minus or negative. So this could be 4 plus negative 6 or 4 minus 6. Either will get you negative 2. So now I know this is my simplified expression. Now the question is going to ask you to evaluate for x equals 3. So now I know that x is equal to 3. So all you have to do is input 3 back into your expression for x. So instead of x now, I'm going to put my parentheses and put 3. Remember, we put parentheses in order to show that that's what we're replacing x for. So every time you replace x, you need to put them in parentheses just in case it's multiplication or an exponent on the outside. And then we're going to add 2 times 3 instead of x, then minus 2. So now we have 4 times 3 squared plus 2 times 3 minus 2. If we look at our order of operations, or PEMDAS, we know that our parentheses come first, but there's nothing to do inside of our parentheses, so we can move on to exponents. Do we have any exponents? We do. We have one right there, so we are going to look at 3 squared. 3, remember, when you square something, that's the number times itself twice. So this is 3 times 3, not 3 times 2. So 3 times 3 is 9. I'm going to keep it in parentheses. We're going to drop everything else down. So 4 plus 2 times 3 minus 2. So then next in my order of operations is multiplication and division. And remember, it could be multiplication or division depending on which one comes first. I only have multiplication in this problem. So 4 times 9 is 36. Plus, what is 2 times 3 is 6 minus 2. So then I just drop everything else down. Now, adding or subtraction, depending on whichever one comes first. So 36 plus 6 is 42. Drop everything else down. Minus 2. 42 minus 2 is 40. That is how you evaluate that expression. So, I want you to remember that before you begin the process, you should simplify your expression as much as possible by combining any like terms that you have. Remember, use that sign in front of the term in order to know if you're adding or subtracting. And then you need to evaluate by replacing x for whatever variable for the number that is provided to you. So you are going to try some problems on the next sheet. You may begin.